Okay, card. I should be in a different outfit tomorrow, but not yet. Same outfit as yesterday. I know, right? You'd think I'd get tired of wearing this stuff, but I just don't. I like wearing gray. What can I say? So I wore it on Monday, and I wore it on Tuesday, and now I'm going to wear it on Thursday. Oh my goodness, that's like 4 days I've been wearing the same outfit. Okay. Don't tell your mom. It'll be okay though. She'll forgive me this one time. So, today is the last day for us to go over these laws of exponents. This is the last major law we have to deal with. When a power is raised to a power, you multiply the exponents. So when I have an exponent raised to an exponent, that's the same thing as if I were to multiply them. So we're going to play around with some situations and make sure that you understand this. So I've got 5 different problems here. If you want, I can give you a few seconds to try them. Go ahead and try them. Okay. Let's see how you did. Just curious. So we said a power raised to a power means we multiply the exponents. So 3 to the 2 times 3 gives you 3 to the 6th. I don't care right now what 3 to the 6th is. I just care that you know how to multiply the 2 times the 3. Right here, negative 2 squared. Well, that means negative 2 times negative 2, which is a positive 4. So that's all good. That's kind of thrown in. It wasn't really a problem out of this, except that you could say that there was a 1 there, and 1 times 2 is 2, but that's not here nor there. Right here, however, 2 to the 3 times 4 is 2 to the 12th. This is another one of those. The question is, what exactly is being squared? Is the whole thing being squared, which means the negative gets written down twice, or is just the number being squared, which means only the 2 gets written down twice? Here, just the number is being squared because the square only applies to what is directly below it. Here, this 4 applies to what is directly below it. Since what's directly below it is this parentheses, it means everything in the parentheses is applied. So everything in the parentheses is what got that power. Here, the only thing that's directly below it is that 2. So technically, this looks like a negative, and then a 2 times 2, which gives you a negative 4. A lot of people mess up that whole negative thing. They think the negative should be counted twice too, but it's not because it's not directly below it. Here, this is directly below that. So this is the same thing as saying negative 2 to the 3rd, all of it raised to the 3rd, and then all of that raised to the 3rd. So that's going to give us negative 2 to the 3 times 3, which is negative 2 to the 9th power. So this is when we have to talk about what does this really mean with exponents and negatives out front. So these are not exponents, these are not negatives on the exponent, because we talked yesterday about how that sent it to the upside down. But that's not what this is. This is a negative out front. So if we have an even number up here, that negative out front will turn out just like it did here. It'll become a positive. If we have an odd number up here, the negative out front will stay negative. So our answer is really negative 2 to the 9th, whatever that would be. We're okay with you leaving it like this. I just need you to understand that that means that it's going to have to affect that. That's how negative and exponents are affected. Let's look at some other examples that are a little bit more useful before we get to classwork and homework. Dome in black. negative 2c over 7d all raised to the second power. Since all of this is raised to the second power, then everything in here gets that second power. And we just said that a negative raised to an even number is going to become a positive. So that took care of my negative out front. It's not there anymore. A 2 raised to the second power is a 4. And a 7 raised to the second power is a 49. So that takes care of that. And then c to the 1 times 2 is 2, and d to the 1 times 2 is 2. That 2 applies to everything inside. Let's have you try one. Take a couple of seconds and see if you can do that one by yourself. Okay. 3 raised to the third power is 27, because 3 times 3 is 9 times 3 is 27. Then a to the 4 times 3, because I get to multiply my exponents. And then b to the 1 times 3. So that's going to give me 27, a to the 12th, b to the 3rd. And then the last one I want you to try, negative 2 h to the 3rd raised to the 5th over 2h to the 4th. Give you a little time. Okay. A negative to an odd exponent makes it a negative, so that's going to be there no matter what. And then 2 had an exponent of 1 times 5 gives me 2 to the 5th. And then h had an exponent of 3 times 5 gives me h to the 15th over 2h to the 4th. Now I have like bases, so I can subtract exponents. You know, the rules from before. They still apply. Just because it's a different section doesn't mean it doesn't still apply. So now I have a negative 2 to the 5 minus 1, because it's division, and then h to the 15 minus 4. So that's negative 2 to the 4th, h to the 11th. And I happen to know that 2 to the 4th is 16. So that's negative 16, h to the 11th. Now you might say, how do I know if you want me to write 2 to the 4th or if you want me to write 16? So here's the rule of thumb. If you know off the top of your head what it's going to be, then you need to go ahead and write the number. So I knew that 3 to the 3rd was 27, so I went ahead and wrote the number. I knew that 7 squared was 49, so I went ahead and wrote the number right there. So I can do that because I know what they are in my head. Now your question should be, well, how do I know whether or not you expect me to know that in my head? Good question. I expect you to know any number squared all the way up through 15 or 20. I expect you to know any number cubed up through 5s. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. 2's like this bottom one here, all the way up through 2 to the 5th probably. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. That's about how much I expect you to know right off the top of your head. And there's really not much more that you'll be learning for those after that. I expect for you to know them. If you don't know them, there's always a calculator there. But don't get upset with me when I leave 7 to the 3rd by itself, because it's not in the list of things that I know off the top of my head. So I don't expect you to know it off the top of your head. If you want to get a calculator and figure out what that is, that's entirely up to you. It doesn't change it. It's not going to make it right or wrong on the test. It's whatever you want to do. Now, there's been a problem in the past with you taking your time doing things because you wanted to make sure you got everything exactly correct. That's great. I'm glad that you are so fastidious about getting everything exactly correct. But you cannot be taking too terribly long on your stuff because you'll never get stuff done. So if everything doesn't look exactly perfect, that's fine. As long as you can read it, we're pretty good. And you know what you can read, because when I'm there and I can't read it, that's when we have a problem. So it's really careful. It's really important that you make things readable for me on the test, but for your homework and your classwork, you're the one reading it, not me. When I get there to grade it, it's, it's not going to kill you to have things a little bit off kilter, as long as you can read it. Now, if you can't read it, there's a serious issue. You need to work on your own handwriting then and do that on your own time, not on math time. Just saying. So, classwork for this section. On page 236. Practice exercises. Numbers 1 through 7 odd. Look at that, just 4. Homework for this section. Page 236, practice exercises. Numbers 11 through 27, odd. It's 9 problems. You can handle 9 problems. It's homework for a reason. You will see me tomorrow. Okay. Bye.